All right, welcome back to COM 3-2. This module we are going to talk about measurement. So if you want to pause here, you can to capture the things that we're going to talk about and pop them into your notes. So what do we mean by measurement? And I put a graphic in here of a lot of the things that you use in your life to measure things. You do this all the time, right? When we talk about measurement, we're just talking about assigning numbers or labels to represent conceptual properties. So that we can understand them with meaning in the world. If we take a temperature with a thermometer, we need to know what the normal temperature is, what it means to have a fever, etc. So we're just systematically observing some characteristic and then recording it in the form of a number or a category. Why do we measure stuff? Well, because it allows for a characteristic to be more effectively organized and understood. When we're talking about measurement in research methods, it's generally following a more deductive view, moving from abstract concepts to specific concrete ways of observing them. So here is another place that you might want to hit the pause button to write these down and then take notes on the definitions. These are important terms that are related to measurement, but they will end up coming up again and again in this class. First, theory. This is just some attempt to explain an aspect of social life and usually includes a set of concepts and their relationships that are proposed. Concepts are the ideas of the theory that the researcher must define, and we're going to talk about that in pretty extensively this module. When we talk about variables, you might remember variables from algebra class. These are properties or characteristics that are associated with a concept that are measured, and variables must vary. There must be at least two values of a variable. So for example, being a human isn't a variable, but being a citizen of a country and having a lot of countries you could be a citizen of could be a variable. Attributes are the range of qualities or characteristics that constitutes a variable. So, for example, if you were talking about this variable of a citizen of a country, it would be the list of all the countries. Those would be the attributes. A constant means that it's the opposite of a variable because a constant doesn't vary, it stays constant, and it doesn't take on attributes. And in the textbook, there's a bit more on this too, and we'll talk about this a bit more in a future module. Hypothesis. Hypotheses is the plural of that word. It's a specific testable prediction about the relationships between variables. And observations are repeated trials from which we draw generalizations. So again, you might want to pause and take some notes on this, but these are terms that are going to come up again and again. And so if you hear them later in the lecture or in the future, hopefully you can have this as a reference. So you can be like, what was a constant? What was the deal with that? These are important. So variables that are going to come up quite often in this class are when variables are considered an independent or a dependent variable. This you might also remember from math in school or from science in school. The independent variable is the variable that is the one that causes or predicts outcomes. This is the X variable. An independent variable must occur in time before the dependent variable. The dependent variable is the variable that depends on the independent variable in order for it to occur. This is the Y variable. X leads to Y. This is the outcome of the independent variable, and it must come later in time. It must come subsequent to an independent variable. So if you're looking at a study abstract and you're trying to figure out which is the independent and which is the dependent, well, the dependent variable needed to come after. So in the social sciences, we spend a lot of time thinking about conceptualization and operationalization. Conceptualization is the process of defining terms that are used in a study And operationalization is deciding how you're going to measure or observe them. Conceptualization, you're going to define the concept, and that's just the meaning attached to the concept or variable, which is usually defined from theory. Conceptualizing something is actually really hard, defining it specifically. So for example, a conceptual definition of intelligence could be: intelligence is the capacity for abstract thought, understanding, communication, reasoning, learning, planning, and problem solving. This is kind of hard. Operationalization is easier. This is translating a construct or a concept into a measure. In general, we don't just invent operationalizations, we usually get them from previous research. The point of operationalization, this turning a concept from an abstract notion into something more specific or concrete, it moves our understanding towards something that we can actually measure and understand. In operationalization, we have to identify observable indicators and procedures, and it's sort of like following a recipe. So for example, we talked about intelligence and its conceptual definition earlier. Now the operationalization could be the score resulting from the performance on a particular intelligence test. IQ is a commonly noted intelligence test. So IQ is a way to measure intelligence. It's very important to note that with conceptualization and operationalization, it's very difficult to get a perfect match. For example, this intelligence test isn't perfect, and it doesn't measure all the ways that we understand intelligence, certainly. So we spend a lot of time thinking about how to overcome the gap between what our concept is and how we are able to measure it. One way to be thinking about this is that there can be things that are manifest. These are factors that are very directly observable: weight, height, etc. They're very easy to measure. Latent constructs or concepts, on the other hand, cannot be directly observed. So for example, self-esteem, social support, political ideology. We can't measure them directly. We have to measure them in a way that we're hoping gets at the idea as best we can, but it is very hard. So when we're trying to actually operationalize something, remember our objective is to find ways to observe the variation in the concept. So the first thing that we do is identify the empirical indicators of the concept. Indicators are specific observations that show the presence or absence of a concept. They might be based on conceptual dimensions, which are aspects of concepts that group together logically, sort of like subgroups operating within the overall meaning of a concept. So for example, in the concept credibility, there are dimensions of expertise and trustworthiness. They're related and they can be measured separately. We tend to measure things with multiple indicators so that we're really trying to capture everything we can about it. And we're really just assigning numbers in order to be precise. It's very important within this that you capture all the possible answers. One year I was teaching COM 382 and some students were working on operationalization, and they were measuring, they were asking people about how much they paid for shoes. And they created categories of $0 to $15, $15 to $25, $25 to $50, $50 to $100, or something like that. And I said to them, well, you know, some shoes cost more than $100. If you had shoes that cost more than $100, what would you answer on this? So you want to make sure that you get all the relevant categories. Also, maybe those particular categories they picked didn't make sense. Have you ever taken a survey and they have age categories and you're like, I'm being asked to be in this age category and that actually doesn't make sense for me. So you want to be really thoughtful about this. Your second aspect of operationalization is to really spell out how exactly you're going to collect data about these indicators. This could be really hard. So you want to be thinking about preciseness. So if you want to pause and take a break here, that's fine. The next topic that we're going to talk about is levels of measurement. When we're talking about variables and how they're measured, the two major categories within levels of measurement are categorical and continuous. There's subtypes that I'll talk about too in a minute. Categorical variables are variables where the values represent discrete parts of things that are being studied. These are variables that use categories for values. So for example, hair color, eye color, nail polish color. These are just categories. You're either in a category or you're not. You either have blue eyes or brown eyes. These are labels, not necessarily numbers assigned to them, although we can, after the fact, give them numbers. Continuous levels of measurement are theoretically unbroken wholes, where parts are not distinguished except arbitrary divisions. These are when we are assigning numerical values. This might seem a little abstract. Let me explain the subtypes and it might be clearer to you. So there's two types of categorical variables. The first one is called nominal. It's like name. This is a variable that's measured merely with different categories. Categories are mutually exclusive, like I was saying. You're either in or you're out. The categories must be exhausted. Everything that someone could actually answer needs to be on the list. And no categories are better than any other. So blue eyes, brown eyes, green eyes, whatever. There's no order to the categories. So nail polish colors, states of residence. Something just fits in one or the other. That's it. Ordinal is another categorical variable, and it's kind of like nominal, but there's rank ordered categories. The easiest example of this is Olympic medals. Gold is the best, then silver, then bronze. They are still categories, gold, silver, and bronze. They don't really have numbers assigned to them. However, one is best, another is not as good, and one is the worst, right? You have gold, silver, bronze. Another example could be freshman, sophomore, junior, senior. They are categories. You're fit into one or the other, but we're not necessarily assigning numbers to them. And there's no real way to know the difference between rankings. It's not that a gold medal is a certain number different from a bronze, which is a certain number different from a silver. So it's still categorical, but there's a little bit of ranking involved. Continuous, on the other hand, are these metric variables that allow us to be precise in the numerical values that we're recording. And there's two types of this: interval and ratio. Interval is a variable that's measured with successive points on a scale with equal intervals. So for example, temperature. We know that 5 degrees is the same difference between 10 as it is 0. We know that 90 degrees heat is as different from 85 as it is from 95. Okay, the intervals are equal. The values lie along an evenly dispersed range of numbers, but you could also do this with like strongly opposed to strongly agree. We make the assumption that the distance between these response options is the same. Okay, is the difference between strongly agree and strongly disagree and agree and disagree the same? Maybe not, but we assume it is. So it's similar to ordinal, except that you have this understanding of the distance between response options. A Likert scale is commonly used for levels of endorsement of a statement, and it is treated as an interval measure. So a Likert scale would be, on a scale of 1 to 5, how much do you enjoy this class? Ratio is just like interval, but it has a true meaningful zero, that there can be a zero level. And a way to remember this is to think of ratio at the end. It's a specific number. Time in seconds, you could have 0 seconds. Weight in pounds, you could have 0 pounds. Years of education, you could have 0 education. Okay, so they're very similar, but remember, ratio has a true zero. When we're coming up with operationalizations, continuous variables are better. You can always make categories later. So for example, if you were measuring people's age, just ask them how old they are. If later you want to categorize people from 18 to 25, 26 to 30, whatever, you can do that later. But start with the most information you possibly can, and that is a continuous measure.
Okay, so another way to think about levels of measurement, if you're trying to understand this better, is that measurement can also be understood as a representation of relationships between objects, people, or groups on a particular property with relations between numbers. So for example, if we are measuring depression, we might use a questionnaire where higher scores indicate higher levels of depression, right? But it's also really important that we know what our measurement isn't capturing. Like for example, a depression questionnaire might capture some symptoms, but not others. Like maybe they aren't asking about particular social factors that might impact depression, especially if they are in a particular context. So levels of measurement allow us to meaningfully interpret for a given property. So for example, if you look at this little graphic here with different heights between people, if we're measuring height or body length, we can qualitatively say that we see some differences between some of these people, right? Just by eyeballing it, looking with our naked eye, comparing side by side. We can see nominally that there are differences, that some of these people are taller than some of the other people. But we could also potentially put these people in order. That would be an example of ordinal measurement. And we can also compare differences with measurement and assign numbers to each height as a ratio. So with this, we can say that measurement values can be related to each other in a lot of different ways in terms of inequality. This is not inequality like social inequality, but that things are not equal. That is, for example, a nominal level of measurement. We know that there are differences between things that we're measuring and they are distinct, but we can only see if they are equal or not. There's no order to them. So nominal, as you know, is like nationalities. Order, aka ordinal measure, we know that there are differences and we know that there's an order. We see that some of these people are taller and some of these people are shorter, but we don't know precisely the differences between each. So for example, maybe a teacher knows who their best student is, but it's not like this student is exactly this much better than another student. And you know, the case we always give Olympic medals. But we also, when we're measuring, can see differences. This is the example of interval. We know that there are differences, we know that there's order, and we can measure the differences. So like, for example, I could heat up 2 different pots of water and measure that one is 180 degrees and one is 160 degrees, the temperature of the water. And then ratios, like a ratio measure, we know that there's a meaningful zero and that zero matters. And this is often used in things we're counting, like how many frogs are on the table, how many inches, how much money do I have? I also just want to reiterate the deal with interval and ordinal. There's more on this in the textbook, and this is going to continue to come up. The technical definition of an ordinal lever of measurement is ranked categories without precise equal distances between them, and everybody agrees on this, like Olympic medals. In the hard sciences, they really need to be precise, right? They're measuring diseases and pollution and things, and so they have to be really strict about the way that they measure things, and if they can't be iffy about it at all. But in the social sciences, if we ask somebody something like, how much do you agree with this, or how much do you like this on a scale of 1 to 5, we treat that as interval. Our hard science peers would not. They would say, no, that's ordinal. Because when you ask somebody on a scale of 1 to 5, how much do you agree with this, from strongly disagree to strongly agree, a hard scientist would say, you don't know the exact number that they mean when they answer that. It's not precise that the difference between two of these points is exactly the same. And if you ask Google or AI, it will think like a hard scientist. But in the social sciences, we strongly believe that people in their minds understand the difference between strongly disagree and slightly disagree to be the same amount as strongly agree and slightly agree. So we treat those kind of measures as interval. It also allows us to do a lot more things statistically, which is a big advantage. So this is really important for you to understand. So with measurement validity and measurement reliability, when we're measuring something, we want to do a really good job measuring our concepts appropriately and completely. We want to make sure that if we are trying to measure happiness, that we are doing a really good job at it. A reliable measure is something that is stable or consistent, both within a single concept's measurement. Like, for example, if you have 4 indicators for one concept, they really should all be correlated with each other, right? And also between different uses of the measure. If I measure happiness on one population and you measure happiness on another population, it should kind of work out the same, assuming that there aren't big differences between the population. And so it's really important when we are developing measures that we're evaluating the measurement's validity and reliability. Okay, measurement validity. I want to give you a little warning that we're going to talk about a different kind of validity in an upcoming measure. And people get this measurement validity confused with this other type of validity. And so have in your mind already that you really want to be thinking about how measurement validity is something specific. Measurement validity is when researchers are measuring what they say they're actually measuring. Basically, if the measurement that they choose is doing a good job at getting to the meaning of the concept that they care about. You can think of validity as being closely related to accuracy. Okay? So, did my intelligence test do a good job measuring the concept of intelligence? There's a couple different kinds of measurement validity that we often talk about. The first one is face validity. And so this just means on the surface. Like if someone just looks at it, they're like, yeah, that seems like a good way to measure that thing. It's the degree to which measurement maps onto a common understanding of a concept. Criterion related validity is if the measurement relates in a logical manner with another variable outside of your study. So, for example, if we know that intelligence is highly correlated with years of education, we would expect that there would be a relationship there. We know that there's a relationship between height and weight. The taller you are, the more you weigh, right? So if you're measuring height in a particular way, then it should relate pretty well to a different way that we know to measure weight. That's criterion related validity. Content validity refers to the degree to which the full range of meanings of the concept are reflected in the measurement. So are you capturing all the different understandings? That example I gave earlier about the cost of shoes. That didn't have high content validity because it didn't get at more expensive shoes. And this is also that if you have multiple measures, that they all make sense with each other. So again, we're going to talk about a different kind of validity later on. So make sure in your notes you're taking closely that this is measurement validity. The other thing we want to think about is reliability. So you know this word reliability. If they say, oh, so-and-so, that's a really reliable person, or oh, that's a really reliable car, it means that it works and we can count on it working. Measurement reliability is the degree to which the same measurement procedure would yield the same result if put in place multiple times. So for example,
if I give this module quiz in this quarter and the questions are all the same as in another quarter, assuming everything went the same, the test results should be pretty similar. Or taking the SAT or the GRE or the ACT test. We assume that people score the same on the SAT year after year after year after year. It's a pretty reliable test. If all of a sudden a bunch of students took the SAT and their scores were wildly different than they had been in the previous year and there wasn't a reasonable explanation, we would question the reliability of the SAT. So there's 3 threats to reliability, 3 things that can mess up your reliability. One is the way that items are created are ambiguous or unclear. And this happens. Sometimes we write test questions that are unclear. We also know that the length of the research instrument can impact reliability. So if it's a really long test, you get tired at the end. So that hurts reliability. The manner in which the research is administered is also really important. It should be administered consistently, clearly, and professionally. All those things can hurt reliability, measurement reliability. There's a couple different ways that we look to test reliability. The test-retest method means that you ask the same question twice to see. So for example, in a survey study that I work on, we ask them at the beginning how many years of education they have in a number, and so people will count. They're like, okay, I had college, I went to school, blah, blah, blah. Okay, 19 years of education. And then later in the study, we ask them in a categorical measure, have you graduated elementary school, middle school, high school, college, etc.? And so those items should be pretty correlated. The split half method is a way to verify if any randomly selected half of the items used to measure a concept will produce the same result as the other half. So if you had multiple ways to measure things, it should really result in the same way. Or if I was giving a spelling test to some kids and I gave half the class a spelling test on some of the words and the other half the spelling test on the other some of the words, well, the results should be the same. That it should be like evenly distributed, the difficulty. Intercoder reliability, that we'll talk about a little bit more in a future module, is a way to compare observations about data across different observers. So imagine that I was asking a group of you to watch a cartoon and count the number of times that there's violence in the cartoon. Intercoder reliability would be a comparison between 5 different people in the class doing this and the numbers that they came up with. Because my hope would be that all of you would come up with the same number. So when we do a study, we really have to think about how we can balance validity and reliability, because they are hard to have both. So in this visual, you can see that studies that are highly reliable but weak on validity will produce similar results, but the results are wrong. So for example, you could have a scale, a bathroom scale, to weigh yourself every day. And if it's 5 pounds off, but every day it's 5 pounds off, it's very reliable. But then if you go to the gym or the doctor's office and the scale gives you a totally different reading, then your scale, it might have been reliable at home, but it's not very valid because it doesn't have results that are similar with another measurement. On the other hand, studies that are really strong in validity but weak on reliability are all over the place because the conceptual target isn't being hit. So here's a bit more about measurement validity versus measurement reliability. We often say that there is a tension between measurement validity and measurement reliability. If we want to capture something really well and accurately, it's possible that we won't measure it as reliably, because it's difficult to achieve high measurement validity because things happen in different contexts, different nuances. There's a ton of variability in concepts that's very difficult to capture quantitatively.
We want to have good, reliable measures that can capture things regardless of context. And so we can't do this very easily when there's a lot of variability. So what kind of choices do we make? Well, if we're doing an early exploratory study, we're just developing a brand new concept, we probably are going to care more about validity in our measurement because we're really trying to figure out what is all going on within that concept. Can we really capture it? Measurement reliability tends to come later and is more important when you're working with an established measure or you're trying to do comparisons. So it's not that like one is more important than the other. It's more about the stage of life that concept and its measurement is in. Another thing we want to be thinking about that's a big drawback of quantitative research is that a lot of operationalizations don't do a good job at allowing marginalized voices to come through. So when we're doing operationalizations ourselves, we really need to be thoughtful. So for example, creating gender questions that have more options than just woman and man, and have an open-ended option. Let people type it. Now, a downside to this is that if you're the researcher, you're going to have to take time to read those open-ended options, but we would say that it's worth it to make sure that people are able to express their identity. Also, allowing people to check off as many racial or ethnic identities as they want. When one is designing these kind of operationalizations that are so tied to people's identities, it's a really good idea to do pilot tests with relevant community members to see how they feel about how you're phrasing things. And this is a point at which it's so important to engage in reflexivity because you want to make sure that you're capturing people's truths.